Good morning, students. So, we are discussing about finding the first part of a complete solution of higher order ordinary differential equation, that is complementary part. So, we have solved some examples from the first case of complementary function. So, let us see some more examples on this. Solve d cube minus 6d square plus 11d minus 6 into y is equals to 0. So, this is already in the symbolic form, which is represented already in the symbolic representation. So, we will directly go to the second step, that is finding the auxiliary equation of the solution. Just by replacing m in the place of a d, we will get the auxiliary equation, that is m cube minus 6m square plus 11m minus 6 is equal to 0. Take this one as a equation number 2. So, this is a third order ordinary differential equation. So, how many roots you are expecting for this? You can get 3 roots from this equation. M cube means definitely you will get 3 roots. So, the first root, we will find that first root by using one particular method, which is called inspection method. I think you heard about the inspection method. We can say that is the trial and error method also. First, we have to start with the plus or minus 1, and the second plus or minus 2, plus or minus 3, and so on. And to get the value is equals to 0, which satisfies this equation, we will say that is the inspection method. Let's solve this one. So, what is the auxiliary equation? That is m to the power of 3 minus 6 m to the power of 2 plus 11m minus 6 is equals to 0. So, by the inspection method, we will solve this one. To find the 3 roots, we will get the 3 roots from this equation. To find that 3 roots, we will use this inspection method. So, just first take m is equals to 1 by the inspection method. So, first take m is equals to 1. If it is satisfies this equation, that means that is equals to 0, then you can say m is equals to 1 is the first root of our equation. M is equals to 1 is the, out of 3 roots, this is the first root of the equation. So, substitute this in this auxiliary equation, m is equals to 1. So, this is m cube means 1 minus 6 plus 11 minus 6. Minus 6 minus 6 is minus 12. Plus 11 plus 1 is plus 12. This is equals to 0. That means this satisfies this given equation. Satisfying the equation, that means m is equals to 1. Therefore, m is equals to 1 is the one of the root of our equation. Now, using this m is equals to 1 first root, we will find the remaining roots of the equation. So, in order to get the remaining roots of the equation, we will use the synthetic division method. If you know about the synthetic division, apply the synthetic division method to get the remaining roots of the equation. So, how to find the synthetic division? In order to get the roots, first write the coefficients of the variables. Write the coefficients. M cube coefficient is 1 and m square is minus 6 plus 11 minus 6. We have to divide this one with the first root, that is 1. And here, the second row, it is always equals to 0. Now, we have to add these two to get the second degree. This is the third degree equation. Third degree equation, we will get the second degree equation now. So, 1 plus 0 is 1. Now, multiply these two. 1 into 1 is 1, and that you have to keep here 1. Minus 6 plus 1. is minus 5. Minus 5 into 1 is minus 5. Substitute in the here. So plus 11 minus 5 is plus 6. 6 into 1 is 6. Keep here 6. Minus 6 plus 6 is 0. Now this is the third degree equation and it is the second degree equation. Look at the last row. This is the last row and the second degree equation means the coefficients of a variable. I will write coefficients of variables. This is first one is m square minus 5m plus 6 is equals to 0. So this is the quadratic equation. Now you can find the remaining roots of the equation. So find the factors of the equation. So m square minus 3m minus 2m plus 6 is equals to 0. So take plus m as a common term out of these two terms. Remaining are m minus 3. Take minus 2 as a common. Remaining is m minus 3 is equals to 0. So now write the product of two terms, that is m minus 3 and the remaining is m minus 2 is equals to 0. So we will get the roots like m is equals to plus 2 and plus 3 and this is also one of the root. So we will get the 1, 2, 3 as a roots of our equation. So if you observe the roots, are they real or complex? These roots are real roots. Distinct roots are same roots. Real, these are distinct roots, different. So we can apply the first case. When the roots are real and distinct, how will you write the required solution? That is yc, or you can simply write y complementary function is equals to c1 e to the power of first root into x. You can write whether 2 or 1. So I am taking 1 as a first root. First root, that is 1 into x, plus c2 into e to the power of second root, that is 2x, plus c3 e to the power of 3 into x. So this is the required solution of the given differential equation. So in order to get the roots of the equation, first we have to use the inspection method to find the first root of the equation. Suppose it is not satisfying the given differential equation. In that case, what we have to do? We have to check for m is equals to minus 1. Again, this is also not satisfying, means check for m is equals to plus 2. Again minus 2, plus 3, minus 3, like that. We have to find the first root of the equation. Using that first root, use the synthetic division method and find the remaining roots of the equation. And that roots, observe the roots, you can apply the cases, first case or it may be the second case, write the required solution. Okay. See the next example on this same method. So solve d cube y by dx cube minus 13 dy by dx plus 12 into y okay, synthetic division. So this is also on the synthetic division only. Here I will explain synthetic division. So d cube into y over dx cube minus 13 dy by dx plus 12 into y is equals to 0. So first we have to write the given differential equation in the symbolic representation just by introducing capital D in the given equation. So this is d cube, capital D cube minus 13d plus 12 into y is equals to 0. Take this one as a equation number 1. So now find the auxiliary equation just by replacing m. It is m cube minus 13m plus 12 is equals to 0. Take this one as a equation number 2. So here find the roots. This is also third order ordinary differential equation. So m cube means you will get the 3 roots from this one. You will definitely get the 3 roots. You will have a 3 roots for this equation. So using the inspection method, find the first root of the equation. just by taking m is equals to 1. First take m is equals to 1. If the m is equals to 1 is not satisfying, then go to minus m is equals to minus 1. First check for the m is equals to 1. What is our auxiliary equation? That is m cube minus 13m plus 12 is equals to 0. By using the inspection method, suppose take m is equals to 1. Substitute in the equation 1 minus 13 plus 12. So minus 13, this is plus 13 is equals to 0. That means it's satisfying the equation. So m is equals to 1 is one of the root of the equation. This is root of the equation. This is the first root of the equation. In order to find the remaining roots of the equation, we will use the synthetic division method. So synthetic division method, first we have to write the coefficients of a variable. M cube is a variable, m is the variable. So coefficients of m cube is 1. We have to write here 1. And the second term, 13 is the coefficient. See, here this term does not contain any m square term. So we have to take 0 as a coefficient. So this term, given term, which is not containing the m square term. So we have to take as a 0. Again write the m term. M term is coefficient is minus 13 and plus 12. So we have to use the first root which we got. We got 1 as a first root. Using that root, we will find the remaining roots. So write here this 1 here. So we have to divide this complete equation. In the first term, always we have to take 0 and add these two terms at these two values. You will get the, if it is a third degree, this is the third degree equation. Okay, you will get the second degree equation. So add these two. 1 plus 0 is 1 and multiply with first root which you got. 1 into 1 is 1 and keep in this second row. 1 into 1 is 1. So that one we have to write here. And as these two values again. 0 plus 1 is 1. Multiply with 1. 1 into 1 is 1. And keep here. Minus 13 plus 1 is minus 12. Multiply with this 1. 1 into minus 12 is minus 12. Keep here. Minus 12. Plus 12 minus 12 is 0. Now this is the required, which we say, quadratic equation. Using this equation, we will find the remaining roots. This is the second degree equation. Second degree equation means the coefficients of variables are m square plus m minus 12 is equals to 0. E. What is E? E. Okay. So this is the quadratic equation. Find the factors of the equation. Just write m square plus 4m minus 3m minus 12 is equals to 0. So now take m as a common term in the first and second terms. M plus 4 is the remaining. And in the third and fourth terms, take minus 3 as a common term. Write the remaining terms. Remaining are m plus 4 is equals to 0. So here m plus 4 and m plus 4 are common terms. Take outside m plus 4. Write the remaining term, that is m minus 3 is equals to 0. Now you can get the roots of the equation. What are the roots? M is equals to plus 3 and minus 4 are the roots of the equation. So m is equals to minus 4 and plus 3. And this is also one of the roots. So we got the 3 roots of the equation which we are expecting. So how will you write the required solution now? So roots are real. real and different types of roots, real and distinct roots. So this is applicable for the first case, which is y is equal to c1 into e to the power of minus 4 into x plus c2 into e to the power of 3x, which is the second root, plus c3 into e to the power of third root, which is 1 into x. This is the required solution. Okay. So let us see another example on the synthetic division. So solve d cube minus 7d minus 6 into y is equals to minus 6 into y is equals to 0. So it is already represented in the symbolic form of the equation. So directly go to the step number 2, which is finding the auxiliary equation. So just by replacing m in the place of a d, you will get the auxiliary equation. So m cube minus 7m minus 6 is equals to 0. Take as a equation number 2. So again use the inspection method. First check for the m is equals to 1. If it is satisfying this equation, that means if you get that value is equals to 0, that means this m is equals to 1 is one of the root. So this is the d cube is there, m cube is there. That means you will definitely get the 3 roots from this equation. So check for m is equals to 1 now. So substitute here in the equation number 2, 1 minus 7 minus 6. 7 minus 6 is minus 13. Minus 13 plus 1 is minus 12. Minus 12 is not equals to 0. So m is equals to 1 is not our first root, which is not satisfying. So this first m is equals to 1 is fails. Again check for m is equals to minus 1 now. So substitute in this m square, that means m cube, that means auxiliary equation. So this is m cube minus 7m minus 6 is there. We are checking for m is equals to minus 1. That means minus 1 minus 7 into minus 1 is plus 7. Plus 7 minus 6. So minus 1 minus 6 is minus 7. This is plus 7, which is equals to 0. That means it is satisfying the equation. So m is equals to minus 1 is the one of the root of our equation. So using this first root, using this minus 1, we will use the synthetic division method to find out the remaining roots of the equation. So now write the coefficients of the variables, that is, what is the coefficient of m cube? M cube is 1. So this term, m square term is completely not there. So we will take as a 0. So m coefficient is minus 7 and minus 6. We have to divide with minus 1, which is our first root, minus 1. So always we have to take here as a 0. So add these two, we will get the second degree equation, which is the last row of the synthetic division. So 1 plus 0 is 1. Multiply with this minus 1 now. Minus 1 into plus 1 is minus 1. Again add these two. Minus 1 plus 0 is minus 1. Minus 1 into minus 1, you have to keep here. Minus 1 into minus 1 is plus 1. Minus 7 plus 1 is minus 6. Minus 6 into minus 1 is plus 6. And these two becomes cancels. Minus 6 plus 6 is 0. Now you will get the second degree equation. So write the quadratic equation, that is the second degree equation means the coefficients of a variables. What are the coefficients of a variable? M square minus m minus 6 is equals to 0. So factorize this one, we will get the factors like m is equals to minus 1. So this is our first root which we got here. This is the first root, and from this quadratic equation you will get the roots like minus 2 and plus 3. So these three are the required roots which we are expecting. Roots are minus 1, minus 2 and plus 3 are the roots of our equation. So in order to write the required solution, these roots are real and distinct. these roots are real and distinct. So y is equals to, how will you write? Y is equals to c1 e to the power of first root into x. M is the first root. So take this one as a m1, m2 and m3 plus c2 e to the power of m2 into x plus c3 e to the power of m3 into x. So c1, our first root is minus 1 into x plus c2 e to the power of second root into x, that is minus 2 into x plus c3 e to the power of 3 into x. This is our required solution. Okay, so this is about the first case. When you get the roots like real and distinct, you have to write the required solution in this form. So let us see the second case example. To solve, d cube minus d square minus d plus 1 into y is equals to 0. So this is also represented as a symbolic form. Directly go to the auxiliary equation. So m cube minus m square minus m plus 1 is equals to 0. So out of these two terms, I am taking m square as a common. Now what are the remaining terms here? Remaining is only m minus 1. So now out of this third and fourth root terms, take minus 1 as a common. Remaining roots are plus 1 plus m and minus 1 plus minus 1 is remaining term is equals to 0. Now m minus 1 is the common term. Take it outside. Remaining are m square minus 1 is equals to 0. So m is equals to plus 1 and m square minus 1 is equals to 0. If I take this minus 1 to the opposite side, it will become plus 1. So if I remove the square from here, it will become plus or minus 1. So now what are the roots of the equation? M is equals to 1 and this plus 1 and minus 1. So if you observe the roots, now these roots are real and repeating roots. So out of these three roots, 2 are repeating and 1 is not repeating root is there. So in case of a real and repeating roots, how will you write the required solution? So I think I explained in the previous class how to write the second case, that is real and repeated roots, that is y is equals to c1 plus c2x into e to the power of, first we have to focus on the repeating roots, c1 plus c2 into x e to the power of m into x, m means that repeating root into x, plus c3 e to the power of m2 into x, that means that root which is not repeating, plus and so on. So we will substitute here that y is equals to, our roots are 1, 1 and minus 1 is there. These two are repeating. So c1 plus c2 into x e to the power of repeating root is 1 into x plus c3 e to the power of remaining is minus 1 into x. So this is our required solution when you get the roots like real and repeated. Okay. See the next example, you will better understand. Solve d square minus 6d plus 9 into y is equals to 0. Write the auxiliary equation. This is the quadratic equation. You will solve the equation just by finding the factors of the equation. M square minus 3m plus 9 is equals to 0. Take m as a common term. Remaining are m minus 3 and here out of these two, take minus 3 as a common. Remaining are m minus 3 is equals to 0. So m minus 3 and this m minus 3 is equals to 0. So m minus 3 into m minus 3 is m minus 3 square is equals to 0. So here I can write m minus 3 square as a m minus 3 into m minus 3. That is m minus 3 is equals to 0 and m minus 3 is equals to 0. So what is m? M is plus 3 and m is plus 3. So we got the roots like 3 and 3 which are real and repeating roots. So in case of a real and repeating, how will you write the roots? Y is equals to c1 plus c2 into x into e to the power of repeating root into x. This is only the required solution. Okay. So This is about the second case when the roots are real and repeating roots. So now we will see the examples on the third case when you will get the roots like real and complex, or a real and repeating, or a real or a complex roots or repeating roots. In that case, how to write the required solution? Let's have a problem. B cube minus 8 into y is equals to 0. So write the auxiliary equation now. So what is the given equation? So given equation is b cube minus 8 into y is equals to 0. So this is already in the symbolic representation. So write the auxiliary equation first. The auxiliary equation is m cube minus 8 is equals to 0. Just by replace m in the place of a d. So here, can I write m cube minus 8 as a 2 to the power 3, 2 cube? It is also 8. So m cube minus 2 cube is equals to 0. So I just simplifying this one. So it is in the form of a cube minus b cube formula. So it's in the a cube minus b cube form. So what is a cube minus b cube formula? Apply the formula first. What is a cube minus b cube? It is a minus b, a square plus ab plus b square. This is the formula. You have to remember this one. So apply here now. So this is a cube and it is a b cube. So a minus b, that is m minus 2, into a square, that is m square plus 2m plus b square is 4, is equals to 0. So here we will get the first root, that is m is equals to 2. This is the first root of the equation. So we want again 2 roots because it is m cube is there. We are expecting 3 roots from this equation. So this is the first root of the equation. Now this is the in the form of ax square plus bx plus c. M as a variable. So it's in the quadratic form. So apply the Sridhar's law or a quadratic equation formula, that is m is equals to minus b plus or minus root b square minus 4ac by 2a. That means what is a here? A is 1. And what is b? B is 2. And c is 4. So right, minus b, that is minus 2 plus or minus root b square means 2 square, that is 4 minus 4ac. A is 1 and c is 4 over 2 into a, that is 1. So minus 2 plus or minus root 16, this is 4 into 4 is 16. Minus 16 plus 4 is minus 12. Minus 12 by 2. So minus 2 plus or minus 12 can be written as minus 4 into 3. Minus 4 into 3 over 2. So minus 2 plus or minus, now take this one outside, this minus 4, if you take outside, out of the root, you will get 2 into I, that is imaginary part, into root of 3 over 2. So now divide this one 2 with the numerator, you will get minus 1 plus or minus these two cancel, remaining terms are I into root 3. So this is the second root, which is the complex root of the equation. One which we got, that is the real root, that is m is equals to 2, and complex root minus 1 plus or minus I root 3 is the another root. So roots are complex. So roots are in the case of roots, complex roots. How will you write the required solution? So therefore the general solution, that is y is equals to c1 e to the power of
यहाँ पर -1 कैसा है मैम? -2 है ना वहाँ पे?
See, split this one, -2. This 2 is applicable for both -2 and this completely, right? So -2 over 2, -2 by 2 plus or minus 2i√3 by 2. Oh, okay, just
ओके मैम।
split this one. So this 2 and this 2 cancels, remaining is -1. And this 2 cancel, plus or minus i√3 is the remaining. Okay. So in the case of writing the general solution, how will you write the general solution? It is C1 e to the power of, first focus on the complex roots first. That is C1 cos bx, where b stands for the imaginary part of the root. C1 cos bx, where b is nothing but the imaginary part, plus C2 into sin bx. So this b also nothing but the imaginary part into e to the power of a into x, where a is the real part, plus C3 e to the power of the remaining parts, the remaining roots of the equation, plus m3 and so on. So in this one we have to write the general solution. So y is equal to C1 into cos, what is the imaginary part? √3 into x, plus C2 into sin √3. B stands for a imaginary part, √3 into x, into e to the power of a is nothing but a stands for the real part, that is -1 into x, plus root, this 2 is also our one of the root, so C3 into e to the power of 2 into x. This is the writing method when you will get the roots like real and complex. First write the C1 cos bx, that means imaginary part into x, plus C2 sin imaginary part into x, into e to the power of real part into x, plus C3 e to the power of the real root, which is the remaining root of the that roots, real remaining root into x, plus and so on. In this one you have to write the remaining roots. So see the next example. D to the power 4 plus m to the power 4 into y. So solve d to the power 4 plus m to the power 4 into y is equals to 0. So I just simplify this one by writing, can I write d to the power 4 as a d square whole square? Yes, I am writing d square whole square, d power 4 as a d square whole square, plus m to the power 4 as a m square whole square is equals to 0. So now if you observe this one, it is in the form of a square plus b square. So you can apply the a square plus b square formula, that is a plus b whole square minus 2ab. Apply the formula and simplify the remaining terms. So this is the a square and it's the b square, that is a plus b whole square, that means d square plus m square whole square minus 2ab. A is d square, b is m square is equals to 0. So d square plus m square I am keeping as it is, minus, so instead of 2 I am writing √2 d into m whole to the power square. So that means √2 square is 2 into d square into m square is equals to 0, just for the simplification. Now it is in the form of a square minus b square. So apply the formula to simplify this one. So a square minus b square is a plus b, a minus b. Substitute in the formula, that is a square What is a? A is a d square plus m square plus b square is root 2 d into m whole square. That is a plus b into a minus b. That is a is d square plus m square minus root 2 d into m. A plus b, a minus b. This is a and this is b. A plus b, a minus b. B term is equals to 0. Now we will solve the first term and second term, which is equating to 0. D square plus m square plus root 2 dm is equals to 0, and d square plus m square minus root 2 d into m is equals to 0. We will solve one by one. First, solve the first term, that is d square plus root 2 m into d plus m square is equals to 0. Take this one as the equation number 1. By applying the quadratic formula, solve this one. Again we will solve the second term. So d is equals to minus b, that is minus root 2. So it is in the form of ax square bx plus c is equals to 0. So what is a here? A is 1. D as a variable. So d is equals to a is 1. And what is b? B is root 2 into m. What is c? C is m square. So substitute here now. Substitute in the formula, that is minus b. Minus b means minus root 2 into m plus or minus root b square. B square means 2 into m square. B square minus 4ac. A is 1, c is m square over 2 into a. 2 into 1 is 2. So now minus root 2 into m plus or minus root 4m square plus 2m square is
Excuse me,
minus
ma'am. What
2m
is
square.
x square?
What is, where is x square is there?
A square
Ax
plus
square.
b.
This is the, yes,
Ax
this is
square.
the just, it's a quadratic equation form. Ax square bx, it's in the form of this one. I am saying that one. This is the quadratic equation form, d square plus root 2 into md plus m square. Okay, this is just a form, quadratic form. You have to apply the quadratic equation, quadratic formula for solving this one. Okay. Over
Okay.
2. Okay. So root minus root 2 into m plus or minus. So minus 2m square is there. I will take m square outside. This, if I take minus m square outside, so minus becomes imaginary, that is I into m into root 2 plus or minus root 2 into m I am keeping as it is divided by 2. So now d is equals to, so if I take root 2 as a common term, take root 2 as a common in the numerator, and what are the remaining terms? M plus or minus. So this is minus as it is, minus m plus or minus I into m as a remaining terms over 2. So see, you can solve this one using synthetic division also. Synthetic division lindu ಮಾಡಬಹುದು ನೀವು. So I am just using this factorization method. So see, now you can, 2 can be written as a root 2 into root 2. Now what are the terms? And this root 2 and 1 root 2 get cancelled. Now you can write minus m over root 2 plus or minus I into m over root 2. This is the first root of the equation. Again, for solving the second term, which is equation number 2, d square plus m square minus root 2 into d into m is equal to 0. We will solve this one. So d square minus root 2 into m into d plus m square is equal to 0. So this is one of the root of the equation. We will use this one while writing the general solution. So now again use this one using the quadratic form, that is minus b. What is minus b? That is minus minus becomes plus. What is b? b is minus root 2 into m. So it will become root 2 into m plus or minus root b square. Root b square means 2 into m square minus 4ab. A is 1, b is m square over 2 into a. A is 1. That is 2 into 1 is 1. So root 2 into m plus or minus, it will become minus 2m square. Minus 4 plus 2 is minus 2. M square as it is over 2. So now take, as we solved in the previous, take the minus m square as a outside, out of the root. So root 2 into m plus or minus, so it will become I into m into root 2 as it is over 2. Take root 2 as a common term in the numerator, write the remaining terms. Remaining are m plus or minus I into m is the remaining term. So over 2 as it is, 2 can be written as a root 2 into root 2. 1 root 2, 1 root get cancelled. What are the roots of the equation? M by root 2 plus or minus m into I over root 2. This is the second root of the equation. So we got the roots like complex roots. So how to write the required solution in the case of a complex root? That is y is equal to, so y is equal to c1 into cos bx. B means the first root, the imaginary part of the first root. What is the imaginary part? That is m over root 2 into x. c1 cos bx plus c2 sin bx. What is b? b is m by root 2 into x plus e to the power of a real part. What is the real part here? Real part is minus m by root 2. Minus m by root 2 is the real part, and this one is the imaginary part. So I will write here minus m by root 2 into x. Okay, plus again the second root which we got. Again c3 into cos bx. What is b here? Imaginary part is m by root 2. M by root 2 into x plus c4 sin. Sin imaginary part is m by root 2 into x into e to the power of real part, that is m by root 2 is the real. M by root 2 into x. So this is the complete solution of the equation. Okay. So this is about the finding the first part, which is the complementary part of the solution. This completes here. In the next class, we will discuss how to find the second part, which is particular integral. How to find the particular integral of the equation to get the complete solution of the given differential equation. Okay. So any doubt in this finding the particular integral complementary function? So I will continue in the next class.